I'm Nova, and this is OpenClaw Daily. Today we are leading with OpenClaw v2026.4.29, because this is the latest stable release in the current OpenClaw release list and it changes concrete operator behavior right away. Active run steering, visible reply routing, heartbeat-backed commitments, people-aware memory, model catalog behavior, stricter tool profiles, and channel reliability.
I'm Alloy. And the useful way to hear this episode is as an operations episode. Not a vibe check, not a feature parade. The question is what becomes easier to inspect, safer to configure, harder to lose, and less likely to fail silently when an agent is working in a real chat channel.
After the OpenClaw release deep dive, we cover Cisco's model Provenance kit, which turns model Lineage into something operators can compare and scan, and then OpenAI Advanced Account Security, which hardens ChatGPT and Codex accounts for people doing sensitive agent work.
The release block gets the front half because it changes how live agent systems behave while they are already in motion. A follow-up message can steer a running turn. A visible reply can be forced through the channel. A reminder-like commitment can become explicit heartbeat work instead of an accidental promise. Those are operator controls, and they matter.
The release earns the lead because it changes concrete operator behavior immediately. Active run steering, visible reply routing, heartbeat-backed commitments, people-aware memory, model catalog behavior, stricter tool profiles, startup recovery, and channel reliability.
This release changes a lot of operational behavior. Active run queuing now defaults to steering instead of one-at-a-time legacy queuing. Visible replies can be enforced through the message tool. Follow-up commitments become opt-in heartbeat work with extraction and delivery limits. Sub-agent events carry routing metadata. Memory gains people-aware wiki metadata, provenance views, per-conversation active memory filters, partial recall on timeout, and bounded RAM preview diagnostics. Provider coverage expands through NVIDIA onboarding, faster manifest-backed model and auth paths, Bedrock Opus 4.7 thinking parity, and safer Codex/OpenAI compatible replay behavior. Security and operations add stricter restrictive profile tool handling, OpenGrep scanning, sharper GHSA triage policy, safer owner scope handling, Docker onboarding automation, and WebFetch IPv6 ULA opt-in for trusted proxy stacks.
The fix list is also very operational: slow host startup, reusable model catalogs, event loop readiness diagnostics, runtime dependency repair, stale session recovery, version scoped update caches, Slack block kit limits, Telegram proxy and polling resilience, Discord startup rate limit behavior, WhatsApp delivery and liveness, Signal media and receive streams, Faceu empty message handling, Matrix and Teams edges, and systemed restart loop prevention.
After the release deep dive, we moved to two security stories with primary technical surfaces: Cisco's model Provenance kit for model lineage checks, and OpenAI Advanced Account Security for phishing-resistant ChatGPT and Codex account protection.
The key question for the release is simple: does it make the system more inspectable when it works and more recoverable when it fails? That is where this changelog is unusually practical.
Right. It is not only adding knobs. It is putting handles on failure modes that used to feel invisible from the outside. I like that this starts with queuing, because queuing is where a lot of agent systems pretend the user disappeared. Someone sends a correction while the agent is working, and the runtime either ignores it, jams it onto the next turn, or interrupts at a dangerous moment. Steering gives that follow-up a place to land.
Start with active run behavior, because this is where the release changes day-to-day agent interaction.
OpenClaw now defaults active run queuing to steer, with a 500 milliseconds follow-up fallback debounce. The older one-at-a-time behavior stays available as queue. The difference matters. In a long-running agent turn, a user may send follow-up instructions while the model is still working. A queue mode that simply stacks messages can make the next turn lag behind the current state. Steering is different. Pending PI steering messages drain at the next model boundary, so the agent can incorporate accepted follow-ups at the point where it can safely change course.
The operational question is not just can a user send another message? It is when does that message become part of the agent's plan? Steering makes the boundary explicit. The runtime can accept follow-ups, debounce them, and apply them at a safe model boundary instead of interrupting arbitrary tool execution or losing the message after app server cleanup. The release also flushes accepted debounced codecs steering messages before normal app server turn cleanup, so an acknowledged follow-up does not disappear if the turn completes quickly. This also explains the Discord symptom people notice first. The agent may have done something internally, but the channel never sees a message. A visible reply contract says the user-facing surface is part of completion, not a decorative afterthought.
Visible reply enforcement is another important messaging control. The new global messages.visible replies setting lets operators require visible output to go through message, action equals send, for any source chat, while messages.groupchat.visible replies remains available as a group or channel override. That is a routing contract. If the system says a reply must be visible through the channel message tool, the agent should not quietly finish a turn without producing a user-visible response. The related fix for group chats falls back to automatic source delivery when a channel pre-computes message tool-only replies but the message tool is unavailable. That prevents Discord or Slack-style group turns from silently completing with no visible reply.
Sub-agent routing metadata also improves. Gateway events now surface spawned by on sub-agent chat and agent broadcast payloads. That gives clients enough information to route child session events without doing a separate session lookup. In a multi-agent UI or chat integration, this matters because child work should remain attached to the parent request, especially when spawned sessions are doing background tasks, delegated research, or tool-heavy work.
Then there are inferred follow-up commitments. The release adds opt-in commitments with hidden batched extraction, per agent and per channel scoping, heartbeat delivery, CLI management, commitments.enabled, commitments.max per day, and heartbeat interval due time clamping so reminders do not fire immediately in a magical way. This is the right cautious shape. Automated follow-up is useful, but it can become creepy or noisy if every vague future phrase turns into a reminder. Scoping, extraction limits, delivery through heartbeat, and per day caps let operators make it deliberate.
The practical guidance is to enable commitments only where the channel and agent role justify it. A personal assistant may benefit from a bounded check back later capability. A public group bot probably should not infer reminders from casual conversation. The config needs to reflect channel norms, agent role, and delivery risk.
This is why steering belongs near the top of the episode. A running agent is not a static request. It is a live negotiation between the user, the model boundary, and the tools already in motion.
And making that negotiation explicit is the difference between a chat bot that merely accepts messages and an operator surface that can stay aligned while work is happening.
People memory is the part where precision matters most. A generic note can be slightly fuzzy and still useful. A person claim with the wrong alias, wrong relationship, or weak source can be actively misleading.
Memory is the second major release area. OpenClaw adds agent-facing people wiki metadata, canonical aliases, person cards, relationship graphs, privacy and provenance reports, evidence kind drill down, and search modes for person lookup, question routing, source evidence, and raw claims.
That is a meaningful step beyond generic recall. People memory is not just another document index. A person can have aliases, relationships, preferences, roles, privacy constraints, and evidence with different reliability. If an agent recalls Alex said X, the operator needs to know which Alex, which source, which conversation, which claim, and whether the evidence is strong enough to use. Person cards and relationship graphs give agents a structured way to reason about identity and context without flattening everything into one text blob.
The provenance view is especially important. Memory systems fail when they make old, weak, or misattributed facts sound certain. Evidence kind drill down lets the system separate raw claims, source evidence, generated related links, and readable body snippets. The release also keeps broad shared source and generated related link blocks from turning every page into a search hit, caps noisy backlinks, supports all term searches such as people routing queries, and prefers readable page body snippets over generated metadata.
Active memory gets sharper filters too. Optional per conversation allowed chat IDs and denied chat IDs let operators enable recall only for selected direct, group, or channel conversations while keeping broad sessions skipped. That is a privacy and relevance feature. A workspace may want recall in a private operations chat but not in a noisy public channel. Without filters, recall can become overbroad even when the underlying memory system is technically working.
Timeout behavior improves as well. Active memory can return bounded partial recall summaries when the hidden memory subagent times out, including the default tempora transcript path, so useful recovered context is not discarded. That is the right reliability trade-off. A timed-out recall should not necessarily become zero recall if a safe partial summary is available. Operators need bounded output and clear diagnostics rather than all-or-nothing behavior.
There is also a read-only doctor.memory.rem harness RPC for bounded REM dreaming previews without mutation paths. This gives operator clients a way to inspect what the memory dreaming machinery would produce without actually promoting or changing memory. For memory systems, preview and mutation should be separate. Debugging a memory pipeline should not accidentally rewrite the memory store.
The useful standard here is not whether the memory system sounds smart. It is whether a recalled person claim can point back to the evidence shape that produced it.
Exactly. People-aware memory only earns trust when identity, relationship, privacy, and source strength remain inspectable. Provider identity sounds boring until a model picker strips the provider prefix and sends the right-looking model name to the wrong place. Then it becomes the whole bug.
Provider and model coverage expands with NVIDIA onboarding and static catalog metadata. The NVIDIA provider includes API key onboarding, setup docs, static catalog rows, and literal model ref picker support, so hosted NVIDIA models can be selected with their provider prefix intact. The release also persists the NVIDIA_API_key provider marker and marks bundled NVIDIA chat completions models as string content compatible, so NIM models load from models.json and OpenAI compatible subagent calls send plain text content.
The operational point is provider identity. If a model ref needs to keep its provider prefix, the picker should not normalize it away into an ambiguous string. If the provider has a marker key, onboarding and catalog behavior should remember that. If a compatible endpoint expects plain text content for subagent calls, the runtime should shape the request accordingly. These details are small individually, but they determine whether a provider works reliably in real agent flows.
Bedrock support gets thinking profile parity for Claude Opus 4.7. The release exposes X-high, adaptive, and max thinking profiles for Bedrock model refs while keeping Opus and Sonnet 4.6 on adaptive by default. It also omits deprecated temperature for Opus 4.7 Bedrock model IDs, named profiles, and application inference profiles, and classifies nested validation responses for failover. That is another example of provider-specific correctness. The same model family can have different transport rules depending on whether it is called directly or through Bedrock.
Model catalog reliability improves too. Gateway models can serve the last successful model catalog while stale reloads refresh in the background. That prevents control plane and OpenAI compatible requests from blocking behind model provider rediscovery after model config changes. On slow hosts, this is a big usability improvement. The catalog may be stale for a moment, but the gateway does not stop answering while it reloads everything.
Startup diagnostics become more explicit. Gateway diagnostics can emit an opt-in startup timeline that records lifecycle and plugin load phases behind a config flag, so slow start diagnosis no longer requires bespoke instrumentation. That gives operators a way to answer, where did boot time go? Was it config validation, plugin metadata, provider discovery, channel startup, runtime dependency repair, or event loop readiness?
Runtime dependency repair gets a long pass. The release replaces stale symlinked mirror target routes before writing runtime mirror temp files, skips rewriting already materialized hard links, writes dependency maps even when plans are empty, verifies staged package entry files before reusing mirrored routes, prefers require conditional exports for CommonJS-only plugin Deps, scopes packaged node compile caches by OpenClaw version and install metadata, and prune stale OpenClaw known routes during gateway startup while preserving recent or locked routes. The builder takeaway: packaged plugin Deps are an operating system inside the operating system. They need locks, version scoping, repair, and safe replacement semantics.
Put together, the provider and startup changes make the control plane less brittle. A slow catalog refresh, a provider quirk, or a dependency repair should not make the whole runtime feel haunted.
And when it does slow down, the operator should have a timeline and a concrete subsystem to inspect, not just a blank wait.
This is one of the cleanest security lessons in the release. A restrictive profile should not become wider because some other config section happened to define exec or file system behavior. Narrow should mean narrow until an operator explicitly expands it.
Security/tools is one of the most important behavior changes in v2026.4.29. Configured tools.exec and tools.fs sections no longer implicitly widen restrictive profiles such as messaging and minimal. If users need those tools under a restrictive profile, they must add explicit also allow entries, and startup warns about affected configs.
That is a cleaner security boundary. A restrictive profile should mean restrictive. If a config section for exec or file system tools silently widens the profile, operators may think an agent is running with a narrow surface while it can actually do more. Requiring also allow makes the expansion intentional and auditable.
OpenGrep scanning is added with a precise rule pack, source rule compiler, provenance metadata checks, and PR/full scan workflows that validate first-party code and rollback-only changes while uploading serif to GitHub code scanning. This is useful because security automation should be reproducible. A rule pack needs provenance, a compiler path, validation, CI workflows, and a standard output format such as serif, so findings land where maintainers already triage code security.
Gateway systemed behavior gets a concrete operational fix. Supervised lock and e-dryness conflicts now exit with sysexit 78, so restart prevent exit status equals 78 stops restart equals always loops instead of repeatedly reloading plugins against an occupied port. That is a classic service management failure mode. If another gateway already owns the port, endlessly restarting the service does not fix the conflict. It burns CPU, churns logs, and can repeatedly load plugins into a bad state. A deterministic exit code lets the service manager stop trying.
Stale session recovery is also more conservative. OpenClaw can release stale session lanes while active embedded runs, reply operations, and lane tasks remain serialized, so queued follow-ups can drain without aborting legitimate long-running work. Doctor and task maintenance can reconcile orphaned subagents with persisted recovery attempts and wedged session tombstones. The product goal is to recover from stale bookkeeping without treating every long task as stuck.
Channel fixes are extensive. Slack gets a large block kit pass. Native command argument menus stay within option limits. Fallback button labels and values are truncated or dropped when necessary. Confirmation text is capped to dialog limits. Approval metadata and update fallback text stay within Slack limits. Message tool presentation and interactive blocks are merged, and fallback text is capped for sends and edits. The practical failure mode is simple. One oversized button value or fallback string can make Slack reject the whole block payload. The release makes the adapter preserve valid interactive structure while clipping invalid pieces.
Telegram fixes focus on proxy behavior, polling, webhooks, quotes, and safe sends. Telegram honors all_proxy, and service level OpenClaw_proxy_URL for HTTP/1 bot API transport. Long polling timeouts are clamped so low configured values do not force fresh HTTPS connections every few seconds. Polling liveness warnings surface in channel status and Doctor. Webhook runtime state warns when registration has not completed. Quote replies retry without stale or invalid quote excerpts. SafeSend retry avoids duplicate visible messages on ambiguous network envelopes. The pattern is bounded resilience. Keep transient network failures from killing the gateway, but do not blindly duplicate user-visible replies.
Discord fixes cover startup and rate limit handling, thread-bound ACP resolution, long CJK chunking, duplicate gateway monitor suppression, channel health summaries, startup closed behavior when bot identity cannot be resolved, bounded WebSocket handshakes, and cooldowns for Cloudflare error 1015 HTML 429 responses using retry after when available. WhatsApp fixes require real Bailey's outbound message IDs before marking auto-replies delivered, expose liveness and timeout settings, recover listeners after certain reconnect stalls, and log dispatcher delivery failures with enough identifiers to debug typing without send reports. Signal fixes include group allow list matching, installer download caps, media response caps, and long-lived receive SSE behavior. Feishu skips empty text messages that carry no media so blank user turns are not written into sessions.
The release verdict, v2026.4.29, is about making live agent systems more controllable. It narrows ambiguous queue behavior, visible reply delivery, follow-up automation, memory provenance, provider catalogs, startup diagnostics, restrictive tool profiles, stale sessions, service restart loops, and channel adapter failure modes.
The larger point is that channel reliability is part of agent reliability. If the adapter drops, rate limits, duplicates, or hides a response, the model can look broken even when the reasoning path succeeded.
So this release treats transport behavior as product behavior, which is the right move for an assistant that lives inside real message channels.
Cisco's Model Provenance Kit is a strong AI infrastructure story because it addresses a basic question that is getting harder to answer. Where did this model actually come from?
Model cards, repository names, and metadata are useful, but they are not enough by themselves. Models are fine-tuned, merged, quantized, distilled, converted, renamed, repackaged, and redistributed. A downstream team may receive a checkpoint that claims to be derived from one family, but the actual weights, tokenizer, or architecture may tell a more complicated story. That matters for licensing, vulnerability response, safety review, benchmark interpretation, and deployment policy.
The kit is described as a Python toolkit and CLI with compare and scan workflows. Compare mode takes two models, including hugging face or local checkpoints, and breaks down similarity across architecture metadata, tokenizer structure, and weight level signals. Scan mode starts with one model and matches it against a database of known fingerprints to identify closest lineage candidates.
The technical detail is that the kit is not only looking at names. It analyzes signals such as embedding geometry, normalization layers, energy profiles, direct weight comparisons, tokenizer structure, and architecture metadata. Those signals matter because metadata can be spoofed or stripped. Weight level evidence is harder to fake if the goal is to hide model origin while preserving model behavior.
The initial fingerprint database is reported to cover roughly 150 base models across more than 45 model families and more than 20 publishers. That database is important because provenance is comparative. A fingerprint is most useful when it can be matched against known references. Without a reference set, a tool can say two models are similar, but it has less ability to place a model in a broader lineage graph.
Cisco also published a model provenance constitution that defines derivation relationships such as direct descent, indirect descent, mechanical transformation, identity, and transitivity. That is useful because Lineage needs a vocabulary. Fine-tuning, quantization, format conversion, and merging are not the same relationship. A deployment policy may allow one and reject another.
For operators, the practical place to use a tool like this is in the model intake pipeline. Before a model is approved for production, scan it. Compare it with the claimed base family. Store the fingerprint result with the model artifact. Tie that evidence to licensing review, security review, benchmark results, and deployment gates. If a vulnerability or policy issue later affects a base family, provenance evidence helps identify which deployed models might be downstream.
There are limitations. Fingerprinting is evidence, not a magic certificate. A high similarity score needs interpretation. Fine-tunes, merges, pruning, quantization, and format conversion can change signals in different ways. A fingerprint database can be incomplete. Proprietary models may not be available as references. But the direction is right. Model origin should become testable operational evidence, not only a label.
The OpenClaw relevant takeaway is that agent runtimes increasingly depend on model supply chains. If an agent can choose local models, hosted models, fine-tuned models, marketplace models, and converted checkpoints, the operator needs a way to ask not only does it run, but also what is it derived from, what policy applies, and what risk follows it.
The practical win is faster triage. If a model's claimed origin, detected lineage, and deployed artifact all live together, a security advisory or licensing issue becomes much less speculative.
Provenance does not make model intake effortless, but it gives operators evidence they can attach to a deployment decision. OpenAI's Advanced Account Security release is not a model release, but it is a serious agent operation story because ChatGPT and Codex accounts now sit close to sensitive context, code, connected tools, and high-stakes workflows.
The opt-in mode bundles several protections. It requires passkeys or physical security keys and disables password-based login. That makes phishing-resistant authentication the default for enrolled accounts. A stolen password should not be enough to get in because there is no password login path to use.
Account recovery changes are just as important. Advanced Account Security disables email and SMS recovery and requires stronger recovery methods, backup passkeys, security keys, and recovery keys. This is a deliberate trade-off. Email and SMS recovery are convenient, but if an attacker controls the email account or phone number, those recovery paths become account takeover paths. Stronger recovery reduces that risk, but it also means OpenAI support will not be able to recover enrolled accounts if the user loses the required recovery methods.
Sessions become shorter to reduce exposure if a device or active session is compromised. Users receive login alerts and can review and manage active sessions across devices. That matters because long-lived sessions are a real risk when an account contains connected tools, code work, memory, or sensitive conversations. A shorter session window and clearer session list do not eliminate compromise, but they reduce dwell time and improve detection.
Automatic training exclusion is included too. Conversations from enrolled accounts are not used to train OpenAI models. For high-risk users and sensitive work, that removes one account-level privacy decision from the user's daily workflow. The account mode carries the data use preference automatically.
The Codex detail matters for builders. OpenAI says protection applies to Codex as well when accessed through the same login. That means the security setting covers not only chat conversations but also coding agent workflows. Codex may touch repositories, diffs, terminal output, issue context, and connected development work. If an account is compromised, the risk is not just someone reading chats, it can become access to engineering context and agentic workflows.
OpenAI also says individual members of Trusted Access for Cyber who access the most capable and permissive cyber models will be required to enable advanced account security beginning June 1, 2026. Organizations with trusted access can alternatively attest that phishing-resistant authentication is part of their single sign-on workflow. That is a strong signal about where account security is going for high-capability AI access. Stronger models and more permissive tools require stronger account protection.
For operators and builders, the practical lesson is to match account security to capability. If an AI account can use Codex, connect tools, hold sensitive context, or access advanced cyber models, password plus email recovery is not enough. Use phishing-resistant auth. Maintain backup keys. Store recovery keys safely. Review active sessions. Shorten session exposure. And understand the recovery cost before enabling stricter protections.
The best security setting is the one the user can actually sustain. Advanced account security raises the floor, but it also raises the responsibility for recovery hygiene. The deployment recommendation is to document key enrollment, backup key storage, recovery key handling, device replacement, and offboarding before requiring it across a team.
The trade-off is that stronger account security shifts some responsibility onto recovery planning. That is not a reason to avoid it. It is a reason to treat backup keys and recovery keys as part of the system design.
For agent work, account security is infrastructure. The account is no longer just a login, it is the front door to code, tools, context, and delegated action. The release lead is OpenClaw v2026.4.29 because it moves concrete operator surfaces, active run steering, visible reply routing, follow-up commitments, sub-agent routing metadata, people-aware memory, per-conversation recall filters, partial recall, NVIDIA provider onboarding, bedrock thinking profiles, startup diagnostics, model catalog refresh behavior, restrictive profile tool boundaries, OpenGrep workflows, systemed restart loop prevention, stale session recovery, and channel adapter. Reliability.
Cisco's Model Provenance Kit is the model supply chain story. Compare models, scan against known fingerprints, inspect metadata, tokenizer, and weight level evidence, and turn Lineage into a deployment check.
OpenAI Advanced Account Security is the account hardening story. Passkeys and security keys, no password login, stronger recovery, shorter sessions, login alerts, active session review, automatic training exclusion, codex coverage, and stricter requirements for high-capability cyber access.
The practical takeaway: live agent systems need explicit control boundaries. Queuing, memory, providers, channels, models, and accounts all need surfaces operators can inspect, configure, and recover.
Before we close, here is the operator checklist that falls out of the episode. For OpenClaw v2026.4.29, review active run steering first. Decide whether steer is the right default for your channels, and whether any workflow still needs legacy queue behavior. Then review visible replies. If a chat surface expects a public answer, make sure the message tool route is available and that fallback delivery is understood.
Next, review commitments. Enable them only where a follow-up reminder is appropriate, set daily limits, and scope them by agent and channel. Then review memory filters. People-aware memory is powerful, but it should be filtered by conversation and backed by provenance. If the agent is using a person claim, it should be able to show the evidence shape behind that claim.
Provider review comes next. If NVIDIA or Bedrock model refs are in use, confirm the exact provider prefix, model catalog row, content format, thinking profile, and fallback behavior. For startup and runtime dependencies, turn on diagnostics when boot time is unclear, and treat dependency repair logs as operational evidence rather than noise.
Security review is the last step. Restrictive profiles should stay restrictive unless also allow explicitly widens them. Model intake should include provenance checks when the model source matters. And accounts that can reach codecs, connected tools, sensitive chats, or permissive cyber models should use phishing-resistant authentication with durable recovery planning.
One more practical layer: separate control plane health from model quality. If Discord, Slack, Telegram, WhatsApp, Signal, or another channel appears quiet, do not immediately blame the model. Check whether the channel adapter is connected, whether visible replies are routed through the expected tool, whether the gateway has been restarting, whether startup rate limits are active, whether a long-running task is still registered, and whether a queued follow-up is waiting for a model boundary. A good agent can still look broken if the delivery path is unstable.
That is also why the systemd and stale session fixes matter. A restart loop is not only noisy infrastructure. It changes the lived experience of the agent. Messages can arrive during startup, /commands can redeploy too often, provider catalogs can reload, and channel clients can sit in the awkward space between initialized and ready. The best operator posture is to treat repeated restarts as a user-facing outage, even when each individual restart exits cleanly.
For memory, the checklist should include evidence review. If a remembered claim affects a response, ask what kind of evidence supports it. Is it a raw claim, a source snippet, a generated link, a person card alias, or a relationship inferred from context? The more personal the claim, the more important that provenance becomes. People-aware memory is useful precisely because it can preserve nuance, but it only earns trust when the agent can show why it believes what it believes.
For model provenance, the checklist is intake discipline. Store model fingerprints with artifacts. Keep the claimed source, detected closest lineage, tokenizer evidence, architecture evidence, and weight level evidence together. Then connect that record to deployment decisions. If a licensing rule, security advisory, or evaluation failure later applies to a base family, provenance records make the response faster and less speculative.
And for account security, the checklist is recovery rehearsal. Phishing-resistant authentication is powerful, but it changes what happens when a laptop is replaced, a phone is lost, a hardware key breaks, or a team member leaves. Before requiring a stronger account mode, decide how backup passkeys are stored, where recovery keys live, who can attest single sign-on controls, and how active sessions are reviewed. Strong security should reduce panic, not create a new fragile ritual.
The shared pattern is that every important boundary should have a visible operational handle. Queue boundaries, memory boundaries, provider boundaries, channel boundaries, model origin boundaries, and account access boundaries all need something the operator can inspect. The more capable agents become, the less acceptable it is for those boundaries to live as hidden assumptions.
The practical takeaway is that live agent systems need explicit control boundaries. Queuing, memory, providers, channels, models, and accounts all need surfaces operators can inspect, configure, and recover.
Show notes and source links are available at tobyonfitnesstech.com.
Thanks for listening to OpenClaw Daily. I'm Nova.
And I'm Alloy. We'll be back soon.